Hello. In the previous video, we talked about the conjugate of complex numbers. So, first of all, let's look how to deal with conjugate of complex numbers. They have some properties. So, the first property is for all complex numbers, Z belongs to set of complex numbers means for all complex numbers. The sum of Z plus its conjugate is always real, right? So if you have any complex number and you add that complex number to its conjugate, you will get the real number. So this is the first property. So the second property is if you have any complex number, if you have any Z belongs to C means any complex number. This means for all complex numbers. Z times Z conjugate is again a real number. If you multiply Z with its conjugate or you add Z in its conjugate, you will get a real number. Okay? So these are the two properties. Okay, so in this video, we will talk about the reciprocal of a complex number. Okay, so what is the reciprocal? So for example, if you have a number, if I ask you to find its reciprocal, you will write 1/5. If I ask you that find the reciprocal of 2, you will write 1/2. If I ask you to find the reciprocal of negative square root 2, you will write 1 by negative square root 2. That means the reciprocal is obtained by flipping the numerator and the denominator. Similarly, if I ask you to find the reciprocal of 3/2, what you will do, you will take this up and you will take it down, 2/3. Okay? So the reciprocal numbers have very beautiful property. If you have a number and its reciprocal, if you multiply these two things, for example, if I multiply this number with this number, 2/3, then these things will cancel out and I will get 1. So it is always true, when you multiply a number with its reciprocal, you will get 1. So this is the way how we define reciprocal of a complex number. So I will say two complex numbers are called reciprocal if their product is equal to 1. Okay, so two numbers are called reciprocal if their product is 1. Okay, here is the notation of a complex number. If Z is a complex number, then reciprocal of Z is 1/Z or Z inverse. Okay, so if Z is a complex number, then its reciprocal is 1/Z or Z inverse. Okay, so it is only true when Z is not equal to 0, because if it is 0, then you cannot write 1/0. Okay, so if Z is 0, then what will be 1/0? It is undefined. So 1/0 is undefined. So Z cannot be 0. Okay, so if Z is not 0, then you can write its reciprocal or its inverse. So here is a method how you can find the reciprocal of a complex number. Here is some calculation method. Okay, so here is calculation method. If Z is equal to A plus B iota is a complex number, then what is 1/Z? 1/Z is 1 over, since Z is A plus B iota, So I will write 1 by z is equal to 1 by a plus b iota. But we don't know whether it is a complex number or a real number. So because the complex numbers are written as a plus b iota, not this way, 1 over a plus b iota. Complex numbers are written some space plus some space times iota. So this number is not in this shape, okay? So this shape, we have to make this shape, okay? How can we convert this number into this shape? Okay, so here is the method. How can you convert? You will write 1 by a plus b iota, but you'll multiply and divide the same thing with its conjugate. In the previous video, we talked about the conjugate. If this is the complex number, then its conjugate is a minus b iota. What's the conjugate? In the conjugate, you take the real part as it is, and the imaginary part is flipped. If it is positive, make it negative. If it is negative, make it positive, okay? So this is called the conjugate. So what you will do, whenever you will write something over a complex number, then in order to write this thing into this standard form of a complex number, you will multiply and divide by the conjugate of the denominator. What's the conjugate of the denominator? It is a minus b iota. So I will multiply and divide by a minus b iota. Okay? Now, multiply the numerator with the numerator. You will have 1 times a minus b iota divided by, multiply these two things, the denominator with the denominator. It is a plus b iota times a minus b iota. Okay? Now, if you multiply up, 1 times a is a, minus 1 times b is b iota. Now, if you multiply these two things, so multiply a with a, which is a square, then multiply a with negative b iota, you will get negative ab iota. Now, multiply this with this, ab iota, then multiply this with this, negative b square iota square. Make sense? Okay. Now, we know from the previous video that iota square is equal to negative 1. So I will put here negative 1. And the rest of the things are as it is. So a minus b iota divided by a square minus, okay, let's look. A plus b iota and ab iota and minus ab iota are cancelled because one is with plus and the other one is with minus. You will left with a square minus b square times minus 1 because iota square is minus 1. This is equal to a minus b iota divided by a square plus b square. Okay? Now we are very close to our aim. Our aim was to write the reciprocal in this form. And this is the form in which you have plus in the center and some real part on the left and some imaginary part on the right. So I can do that. If I distribute this denominator with this term and with this term, what will happen then? So first of all, I will distribute the denominator with the first term. It will be a over a square plus b square. Okay? Now I will distribute this with the second term. The second term is negative b iota. Okay? Now this iota can be written here. Now let's look. This is some real part. This is an imaginary part. This is iota and there is plus. Now you can compare this whole structure with this structure. Okay? So I had a reciprocal of a complex number, but that reciprocal was not in this form. How I converted that reciprocal in this standard form of a complex number? I had multiplied and divided by the reciprocal of the denominator of a complex number. Then we just have some simplification. After simplification, I distributed the denominator over both of the numerator terms. In the numerator, we had two terms, so I distributed the denominator with each of these terms. So this is now a complex number in this form, a plus b iota or x plus y iota. Okay? Yeah, I think we should do an example. In this example, we have to find the reciprocal of 1 plus 2 iota. Okay? So, I have to find its reciprocal. So, I told you the reciprocal of anything is 1 over the same thing. So, the reciprocal is 1 over the same number. The number is 1 plus 2 iota. I will write 1 plus 2 iota. Now, this is the reciprocal, but I don't know whether it is a complex number or not, because my complex numbers are always in this form. Something plus something times iota. So I will convert this into this thing. What will I do? I will multiply and divide the denominator with its conjugate. So what's the conjugate of this thing? If I find the conjugate of this thing, the real part will be as it is, but the imaginary part will be flipped. If it is plus, make it minus. If it is minus, make it plus. So I will write 1 minus 2 iota. So this is the conjugate of the denominator of this complex number. So I will multiply and divide by this conjugate. So I will write a fraction here, 1 minus 2 iota over 1 minus 2 iota. This is what I have to do. It is the complex number. I have to multiply and divide by the conjugate of this complex number. Now, what to do? Multiply the numerators. So, what is this? 1 times 1 minus 2 iota, and multiply the denominator terms with each other. It is 1 plus 2 iota times 1 minus 2 iota. If I make more simplifications, 1 times 1 is 1, minus 1 times 2 is 2. So I will write 2 iota, 1 minus 2 iota, right? And multiply this 1 with 1, minus multiply this 1 with 2 iota, it will be negative 2 iota. Now multiply 2 iota with 1, it will be plus 2 iota, and then this with this, minus 2 iota, 2 square iota square. Okay, 2 times 2 is 4 iota square. Okay, cancel this plus 2 iota with minus 2 iota. So you will get 1 minus 2 iota divided by 1 minus 4 iota square is minus 1. I will write here minus 1. 1 minus 2 iota divided by 1 plus 4, which is 1 minus 2 iota divided by 5. What I have to do now? I will distribute this 5, the denominator, with this one and with this one. Okay? So it will be 1 by 5. So first of all, I will distribute this with this one. It will be 1 by 5. Then plus, I will distribute this 5 with negative 2 iota also. So negative 2 by 5 iota. Now you can check, this is the real part without iota. This is an imaginary part with iota. Okay. So now this is the standard form of the complex number. Okay. In the next example, we will check whether these two complex numbers are reciprocal or not. Okay, I have discussed in this video earlier that if I have a complex number, for example 3 by 2, and we have its reciprocal, which is 2 above and 3 down, 2 by 3, then if I multiply this number with its reciprocal, I should get 1. You can check, this 2 will cancel with this one, this 3 will cancel with this one, you will get 1. So if I have to check whether this number is a reciprocal of this number, so what will I do? I will just show that the product of this number with this number is 1. Okay, here is the proof. So consider 1 plus 2 iota times 1 by 5 minus 2 by 5 iota. Okay, so I will multiply these numbers, and if I get 1, that means both are reciprocal. If I don't get 1, that means both are not reciprocals. Multiply 1 with 1 by 5. 1 times 1 by 5. Now multiply this 1 with minus 2 by 5. It will be 1 times minus 2 by 5 iota. Okay. Now multiply 2 iota with 1 by 5. 2 iota times 1 by 5. Now 2 iota times negative 2 by 5 iota. 2 iota times negative 2 by 5 iota. Okay, 1 times 1 by 5 is 1 by 5. This is negative 2 by 5 iota. So 1 times negative 2 by 5 is negative 2 by 5, and iota as it is, plus 2 iota times 1 is 2 iota divided by 5, right? Plus 2 iota divided by 5. Okay. Now multiply this with this one. Plus minus minus. 2 times 4. Iota times iota square divided by 5. Okay. These two terms will be cancelled. 1 by 5 minus 4 times iota square is minus 1. 1 by 5 minus minus plus. So I will write plus 4 times 1 is 4 by 5. Since they have the common denominator, I can write the denominator as a common, only 1 times 5, and I will add these two things because it is 1 plus 4. If we have two fractions and their denominators are common, then we can add their reciprocals. So 1 plus 4 is 5 by 5. The answer is 1. Oh my god, what does that mean? It means I have multiplied this number with this number and I got 1. This implies that these two numbers are reciprocal. This means 1 plus 2 iota and 1 by 5 minus 2 by 5 iota are reciprocal complex numbers.